Year 13, Chapter 9, Further Differentiation, Lesson 4, a summary of the quick chain rule in action. So we're going to look at the different types of composite function that we have come across and how we can use the quick chain rule to differentiate these very efficiently. So let's start with a power function. So this is where we have our inner function, f of x, being raised to some power n. Now n could be a positive integer power, n could be a fractional power, so this includes roots, n could also be a negative power, so this also includes reciprocal type functions as well. Now when we differentiate this, the derivative dy by dx, well, we need to remember that we multiply by the power n, we reduce the power by 1, so we get n minus 1, and then we multiply by the derivative of the inner function. Now, what about an exponential type function? This is where we have e raised to the power of an inner function f of x, and f of x can be anything. Then dy by dx, differentiating this, we know exponential functions differentiate to themselves effectively, so we get e to the f of x in our answer, but we then need to multiply by the derivative of the inner function, so f dash x. What about a natural logarithm type function? This is where we have y equals ln of some inner function. There's our composite. Now we know ln functions differentiate to 1 over, so this will differentiate to 1 over f of x, like so, but we then again need to multiply by the derivative of the inner function, so multiply by f dash x as per the chain rule. Now, the three trigonometric functions, sine, cos and tan, this is where we have y equals sine of f of x, y equals cos of f of x, and y equals tan of f of x. So we need to remember how to differentiate simple trigonometric functions, sine, cos and tan. We know sine differentiates to cosine, so dy by dx here will start off as cos of f of x, but we must then multiply by the derivative of our inner function, so multiply by f dash x. Similarly, we know that when we differentiate cos, we get negative sine, so this will differentiate to negative sine f of x, but again multiply by the derivative of the inner function. And tan x we know differentiates to sec squared x, so in this case sec squared f of x, but again to complete the differentiation multiply by the derivative of the inner function. So you differentiate the outer function as though it is a power, an exponential, a natural logarithm function or a trig function, and then you multiply by the derivative of the inner function. So here you need to identify what type of functions we have here. So are these power functions? Are these exponential functions? Are these natural logs? Or are they sine functions? Or cosine functions? Or tan functions? Identify the overall or the outer function in each case, and then we'll have a look at differentiating them using the quick chain rule. So I'm going to pause for a minute and I will highlight each of the different types of function using different colours. So one of the crucial things is being able to spot the different types of overall functions. So let's start with the power functions. This is a power function. A square root is a power of a half. This is another power function. Another power function here. Again, we said square root is a power of a half. This function contains exponentials, but overall, it's something being raised to a power. Same here. So these are all power functions. What about functions which are overall exponential functions? So they're e to the power of something. Well, this is an exponential, this is an exponential, and this is an exponential. There may be exponentials in other questions, but the overall function is not exponential in the others. What about natural logs? Which ones involve log of something? This one here, this one here, and this one here, and this one here. They're all ln of something. It doesn't matter what the something is, whether the something contains an e function or a trig function. It's what is the outer function first of all. What about sine functions? Well, we have one here, sine of something. Do we have a cos function? We do, cos of something. And to finish off, do we have a tan function? We do, it's over here. So these are the different types of functions. Can we now differentiate them? So let's have a look at differentiating each of the functions in this activity. You can either work alongside the video or pause the video, work through the questions and then check your answers. So function number 1 here, I'm going to rewrite as y equals 2x plus 3 to the power of a half. So using the quick chain rule, dy by dx is a half 2x plus 3 to the power of negative a half, and then don't forget to multiply by the derivative of the inner function, which is 2. So this leaves us with 2x plus 3 to the power of negative a half, or if you want, 1 over the square root of 2x plus 3. Question 2. It's a simpler question here. Multiply by the power 2, reduce the power by 1, and then multiply by the derivative of the inner function, which is 3. So we end up with 6 bracket 3x minus 1. Number 3, we will rewrite this again as y equals e to the x plus 5 all to the power of a half. And then dy by dx, multiply by that power of a half, reduce that power by 1 to negative a half, multiply by the derivative of the inner function, which is still e to the x. So this leaves us with a half e to the x plus 5 to the negative a half. Question 4. dy by dx, multiply by 2, which is the power, reduce the power by 1 to 1, and multiply by the derivative of the inner function, which is e to the x. So we end up with 2 e to the x minus 3. And then for our last question, question 5, multiply by the power of 2, reduce that power by 1, so it drops down to 1. Now the derivative of the inner function here, this is where we have to be careful. The derivative of ln 5x is 1 over x. And if you're not sure about that, go back to the ln topic to make sure you understand why the derivative of that is 1 over x and not 1 over 5x, which would be wrong. So looking at the exponential functions, we know an exponential function differentiates to itself, but we must multiply by the derivative of the inner function. So the derivative of 2x minus 1 is 2, so our final answer to the first question is 2e to the 2x minus 1. For the second question, again, an exponential function will differentiate to itself. The inner function is 5 minus x squared, so we multiply by the derivative of that, which is negative 2x. So we end up with negative 2x e to the 5 minus x squared. And then the last question, dy by dx, well, this 3, remember at the beginning, is just a multiplicative constant. We'll differentiate to e to the cos 2x, and then differentiate the inner function. So here we have to use the chain rule again and our understanding of trigonometry. The derivative of cos 2x is negative 2 sine 2x. There's quite a lot in this last question. So we end up with negative 6 e to the cos 2x sine 2x. So differentiating natural logarithm functions, we know they differentiate to 1 over the something, which in this case is 4x minus 1, multiplied by the derivative of the inner function, which is 4, and we end up with 4 over 4x minus 1. Second question over here, I would make sure we rewrote this as y equals ln x to the half plus 4. Then dy by dx will be 1 over x to the half, or the root of x, plus 4, multiplied by the derivative of the inner function, which means we need to differentiate root x plus 4. 4 differentiates to 0, and the root of x, or x to the half, differentiates to a half x to the negative a half. So our final answer, I'm going to write it as 2x to the half, x to the half plus 4. And you can also expand that denominator as well rather nicely. Now, next question. dy by dx will start off being 4, because there's a constant multiplicative factor of 4 at the front here, over e to the x squared plus 1. And then we've got to multiply by the derivative of this inner function here, which means you need to access the chain rule again to differentiate e to the x squared. So this is layer upon layer of the chain rule. Differentiating e to the x squared, it's an exponential, so it differentiates to itself, but you then need to multiply by the derivative of the inner function as well, which is 2x. So watch the chain rule being used multiple times in this question. So we end up with 8x e to the x squared in the numerator, all over e to the x squared plus 1 in the denominator. And the final question, dy by dx, we want 1 over tan squared x, but we then need to differentiate tan squared x, and it can be easier to think of it as tan x all squared, and we've got to use the chain rule again to differentiate this. So look at that, it's tan x, but it's being squared, so actually it's a power function. The inner function is a power function. So multiply by the power of 2, reduce the power by 1, and we then have to multiply by the inner function for tan x, the derivative of the inner function, which is tan x, and of course that means we multiply by sec squared x. Now, I think there's probably a lot of simplification that can be done here. 1 over tan squared x is cos squared x over sine squared x. We then have 2 tan x, which is sine x over cos x, and then we're multiplying by sec squared x, which is 1 over cos squared x. So we get a cancellation here and here, and then the sine x here will cancel with one of the sine x's in the denominator here, and our final answer is 2 over sine x cos x. Quite a complex question, this last one. Make sure you've looked at it very, very carefully. You have to use the chain rule multiple times and be really, really very careful as to what type of function you're dealing with at each point of the differentiation. We only have one simple sine question here. We know that a sine function differentiates to cos of the same inner function, but we must then multiply by the derivative of the inner function. The derivative of 3x plus 5 is 3, so the answer is 3 cos 3x plus 5. Very simple question. Cosine functions differentiate to give us negative sine of the same interior function. But what is the derivative of the inner function? It's e to the x. So our final answer, negative e to the x sine e to the x plus 4. And our last question, which is a tan question, we know that tan of x differentiates to sec squared of x. So this will differentiate to sec squared of ln 3x. but then multiply by the derivative of the inner function. And again, this is a bit of a trick question designed to catch people out. What is the derivative of ln 3x? It's 1 over x. It's not 1 over 3x. So this gives me 1 over x sec squared ln 3x.